You are looking at the largest computer in the world. It's massive, isn't it? But guess what? It's not the computer you're thinking of. What you see here is not just a bunch of blinking lights and wires. This is the nervous system of the planet, the largest brain in existence, the Internet. And it's made up of trillions of tiny electronic brains. These are your routers and switches. Do you know what they do? Well, let me tell you a story. Imagine a bustling city full of tall buildings and busy streets. That's our world. Now picture the endless streams of cars zooming around, carrying important packages, delivering them to various destinations. These cars represent your data, your messages, videos, and voice calls, constantly on the move. Now look closely at the streets. Some are wide highways, others are narrow alleys. Each street has signs and traffic lights directing the flow of vehicles. That's your internet infrastructure. The wide highways are high-capacity fiber optic cables and satellites. The alleys are smaller wireless links and cables. The signs and traffic lights are the network rules and protocols. But who ensures that everything runs smoothly, that the data cars navigate the complex network without crashing or getting lost? Meet your routers and switches, the silent heroes of the digital age, always working in the background to keep you connected. This isn't just about wires and blinking lights. This is about the secret brains that run your life. Now that was a story, wasn't it? Well, if you found it interesting, stick around. We bring you stories that make the complicated world of tech simple. Routers and switches are everywhere. You find them in homes, offices, telecom towers, data centers. In fact, you can't access anything online without these two devices. The question is, do we really know how they work? How do they manage to move trillions of data cars every second without a hitch? Well, let's dive into the details. There are two main players in the game, switches and routers. Let's start with the switch. Think of a switch as a traffic policeman standing at a busy intersection. Its job is to control the flow of traffic within a smaller area. Now, what does this mean in the context of data? Well, let's say you've got multiple devices in your house, like a laptop, a smartphone, and a smart TV, all trying to access the internet. They all connect to a central device in your home called a router. But then that router connects to an even larger network operated by your internet service provider, your ISP. And at the edge of that network, acting as the final layer of defense before the big wide internet, you'll find a switch. The switch is responsible for making sure that the data flowing from your house, from your devices to the internet, is delivered to the right place. Without the switch, your devices wouldn't know how to communicate with each other. Imagine trying to send a message to your friend on WhatsApp and it gets lost in cyberspace. Not exactly efficient, is it? This is where switches come in. They help you stay connected. Now, what about routers? Well, think of a router as the traffic director of a city. Just like a city has multiple intersections managed by different traffic cops, the internet has numerous switches managing data within their own areas. But a router is responsible for connecting these different areas together. It's like a highway that allows traffic to move from one part of the city to another. In the world of data, routers connect networks, allowing your information to travel across cities, countries, even oceans. For example, when you're chatting with someone on social media, routers make sure your message goes from your house to the company's headquarters and then to the person you were talking to. It's like sending a letter. Your house is your starting point, the post office is the router, and your friend's house is the destination. The router reads the address on the envelope, sorts it, and forwards it to the right post office for delivery. Same thing with data. Routers read the destination address, decide the fastest route, and forward the data accordingly. To understand how this works, let's talk about the language of the internet, IP. No, it's not some secret code spoken only by tech geniuses. It's actually quite simple. Every device connected to the internet has a unique address called an IP address. This is like your home address, but for computers. And just like your address helps the postal service deliver your mail, IP addresses help routers direct your data. The journey of your data starts with entering an IP address in your browser. Let's say you want to visit a popular video streaming site. Your device communicates this to the router. The router then checks its records, sort of like a phone book, to find the best path to reach the site's location. Once the router finds the right route, it forwards your data along that path until it reaches its destination. Each router checks the address and passes the data to the next one until the streaming site receives it. At that point, the site figures out what you're asking for, processes the request, and sends the video back to you through the same network of routers and switches. Isn't that amazing? It's like a relay race, and the team is the internet. So how do routers decide the fastest route? Well, they use special sets of rules known as routing protocols. It's like the GPS in your phone, but for routers. These protocols allow routers to share information about the status of different routes and make collective decisions. This way, they can avoid congested areas and ensure your data reaches its destination quickly. But hold on. We said that every device needs an IP address. How does that work? Well, it's easier than you think. When you connect to the internet, your device gets a unique IP address assigned to it, kind of like getting a phone number. With that address, your device can communicate with any other device on the network. But you don't need to worry about getting an IP address yourself. That's all handled automatically by the router in your home or office. Now, let's talk about the two main types of IP. You might have heard of them, IPv4 and IPv6. Think of IPv4 as the older version of IP, like the traditional phone system. It's been around for a long time and works fine. But there's a problem. There aren't enough numbers to go around. As more and more devices get connected to the internet, we're running out of IP addresses. That's where IPv6 comes in. It's like an upgrade to the phone system, giving us a practically unlimited number of addresses. So as technology advances and more devices join the internet, IPv6 will ensure that no one is left without an address. But wait, there's more. Routers and switches operate in different modes. Let's talk about them. First, we have static routing. Imagine you're going on a trip and you already know the route you want to take. You might choose a particular road because you know it well. Static routing is similar. The router always takes the same route to send your data. It's like a pre-programmed path. Then we have dynamic routing. Remember how I said routers use protocols to share information? Well, in dynamic routing, routers use those protocols to calculate the best path based on factors like traffic and speed. It's like having a GPS. Finally, there's switching. It's like a dedicated highway lane for certain types of data, ensuring they get priority. And let's not forget about security. Keeping the internet safe is paramount, and routers and switches play a vital role in this. They act as gatekeepers, protecting your network from unwanted intruders. But of course, no system is perfect. There are challenges, too. Congestion, attacks, hardware limitations, power outages. These are the villains that can disrupt the smooth functioning of routers and switches. But hey, even superheroes face tough battles, right? And these guys are constantly working on solutions to tackle these challenges. Now here's something for the future. Imagine routers and switches that can adapt in real time, responding to network changes faster than ever before. Thanks to software-defined networking, SDN, they're becoming smarter, more efficient, and more secure. AI-powered routing is also on the horizon, helping them predict and avoid congestion before it becomes a problem. The future is exciting, and it's happening faster than you think. Okay, class dismissed. So what did we learn today? Well, we explored the world of routers and switches, the unsung heroes of the internet. We learned how they work together to connect us all and keep the data flowing. And we saw a glimpse of the challenges they face and the innovations that are shaping their future. As we wrap up this journey, Remember this: every time you send a message or stream a video, routers and switches are silently working in the background to make it happen. They are the backbone of our digital lives. So the next time you take the internet for granted, just pause for a moment and appreciate the amazing technology that connects us all. That's all for today. I hope you enjoyed this adventure into the world of routers and switches. If you did, don't forget to show your support, and I'll see you in the next video. Until then, stay curious and keep exploring the world of technology.